Chapter 8, Memory. So I've divided up the chapter, as I usually do, into the different units. And I think you'll find it interesting because in this chapter really gets into why I talk about chunking and breaking things down and having an order and why that's important in studying. It has a lot to do with how you encode new information coming in and encoding things well makes it easier to retrieve, basically. So I think you'll enjoy this one, and hopefully you'll come out with some really good study tips going forward. So this section, part one, there'll be a small introduction. Then section one, memory as information processing. I think this is the larger of the sections. It breaks down into sensory memory, short-term memory, and long-term memory. I will be doing a video for part two, encoding, entering information, and that one is quite a bit shorter. So let's get started with memory as information processing. The chapter starts off with an introduction section talking about HM, as they call him, just to point out how interesting and complicated memory can be. So Henry apparently had a surgery where he had most of his hippocampus removed and some surrounding brain tissue due to epileptic seizures. So after this, he lost the ability to form new memories. So he could remember his childhood, he could remember things from a long time ago, but anything that happened in the last 20 seconds, say, he couldn't remember. But what they found is that he could still learn, which is not what you would expect. So they had him, as you can see in the picture there. He is drawing a star, but he can't see the star himself. He has to do it from the mirror image, right? So that makes it more complicated. And what it means is that the more times you do it, the better you get. So you're learning, right? And what they found was his practice improved over time. You've got the 3 days down there. On the left is the number of errors per trial, and on the bottom is the number of trials. So you can see on day one he had a lot of errors. By the time his fifth trial came, significantly less, down to 10. On day two, he started almost at like 10. And then day three, he was making very few errors. But the interesting thing was, each time that he came in to do the tests, he reported that he'd never seen this before. So he doesn't recall ever doing the test before, yet he was learning. Okay, so that was a really interesting finding and really spurred a lot of research on memory processing. So memory is defined as processes that allow us to record and later retrieve experiences and information. So there's two parts to that: recording it and encoding it, and then later retrieving it. So encoding involves translating the neural code into a neural code that the brain can process. Storage is filed away and saved somewhere. It's retained over time, kind of like a hard drive. And then retrieval, where the information is pulled back out when it's needed. A three-stage model of memory is presented in the book, and it's presented that memory as having three distinct yet interacting components. But these do not necessarily correspond to any specific brain structure. So it's sort of a model of how the stages of memory work. So you can see there the three stages. A, the sensory registers, right? So they detect and they briefly hold the incoming sensory information. Then it moves on, encoding, and it goes into working memory, which processes certain information received from the sensory registers and information retrieved from long-term memory. And then the third component is the long-term memory. And this is where information is stored for longer periods of time. It can actually be stored there for your entire lifetime. So next we're going to go into the three stages. We're going to look at the sensory stage, the working memory stage, and the long-term memory stage. So A, sensory memory. This holds incoming sensory information just long enough for it to be recognized. So it's very, very brief, just a few seconds, and it's comprised of two different subsystems. It has iconic stores and echoic stores. Okay, so iconic stores has is the visual information. It lasts for just a fraction of a second, whereas the echoic stores is the auditory information that lasts a lot longer. Okay, so basically what that means is that when we see something, that information lasts just a second, whereas if you were to hear something, that lasts a lot longer than visual. So that the difference in length is important to remember. And this is just a fun picture talking about sensory registers or its initial information processors. So everyone's taking, on the 1st of July or whatnot, and you have those fire sticks and you twirl them around and you can still see the line, right, after it goes. And I mean, that's sort of the purpose of this. Of it. So what that is the light that you see results from the brief, like the duration of the information in your iconic memory, right? The iconic is the visual. And then it says, because of the slow camera shutter speed, this photo captures more arcs of light than you could actually see. Because your iconic memory stores complete information for only a fraction of a second, the image would then vanish, right? And then sometimes you can see that trailing light in your eyes after somebody's been doing it. Right, so that's all iconic memory. Okay, so the next step, the short term or working memory, same thing. So most sensory memory fades away. It's not needed, right? We've talked about this before. Sensory information is constantly bombarding our senses. Most of it, we do not need it. But through selective attention, some of that information is going to enter the short-term memory. Short-term memory temporarily holds a limited amount of information, and it stores and processes information of which we are conscious. It's called working memory because it's consciously coding and processing. It's working on this information, so it's kind of like the RAM of your brain. So once once information leaves sensory memory and it's going into your working memory, it has to be encoded. Okay, and then so the text gets into talking about memory codes, and there's 4 different types of memory codes, also known as mental representation. There's mental images, which is visual encoding. There's sounds, which is phonological encoding. Meaning, which is semantic encoding. And action, which is motor encoding. So one example, say, of motor encoding, like when you're trying to, say, in sports, say soccer, if you're trying to learn a new skill in soccer, new sort of ball control sort of thing, we would be coding patterns of movement, right? How the muscles are working, how just different ways the body's moving. We would be using motor encoding to represent that. It's also important to note that the type of encoding does not correspond necessarily to the original stimulus, which basically means reading. So when you're reading let's say you're reading a sentence or you're reading a paragraph, you're not simply encoding the visual letters because you're looking at letters. More than likely, you're going to encode the sound or the meaning, right? Yeah, so there's different ways of encoding things. And it's not necessarily the same way that that information came into our senses. And that's going to make more sense as we go along. Okay, so we're still in short-term memory. And so we're talking about capacity and duration. So whereas the sensory memory only holds things for like a brief second, right? Um, Working memory holds the amount for the shorter duration, but a little bit longer. It can hold 5 to 9 meaningful units, which that's going to become clear soon. Um, and visual working memory can hold up to 30 meaning units. So what do we mean by meaning units? If you were to have a random, like a phone number, right? The reason you can remember the phone number is because it's not 11 individual numbers. It's 3 meaning units, 3 groups of numbers put together, right? So if the number is 226-973-2244, I mean, I just naturally do that in groups of 3, right? So that's called chunking, and that's taking things and putting them into meaning units. Quite often that's done for us, like phone numbers, like credit card numbers. It's chunked into groups of 4. That's done everywhere. You can also do it yourself, which is what we talk about, which I talk about when I'm studying for things, is I chunk the information in the chapter sort of into meaning units because it's easier to remember than that way for me. Another way to increase duration is rehearsal, which is, as it sounds, it's practicing and repeating the information. That's going to keep it in working memory longer. There's 2 types of rehearsal that they talk about. Maintenance rehearsal is just to repeat it, right? 2673, 2673, 2673, 2673, and just repeat it. Very simple. However, elaborative rehearsal, that you're not just repeating the words or the numbers, you're actually focusing on the meaning or how it relates to other things that we already know. So that is a more effective way in transferring information from short-term memory into long-term memory. The more meaning that we can give a piece of information, the better your brain is able to encode it. Simply repeating something doesn't really give it a lot of meat. It doesn't give it a lot to grab onto. But if you were to change it into a meaning somehow that the brain can encode better, that helps. This graph, it's just a very easy experiment, simple that they did. And what this shows is the retention interval in seconds when participants in a particular study, they were given 3-letter syllables to remember, but they were not allowed to rehearse it, right? They were just given these 3-letter syllables and then asked 9 seconds later, asked 12 seconds later, asked 15 seconds later to repeat back. And at the end of 18 seconds, there was almost no retrieval, illustrating the rapid forgetting of information in short-term memory if you do not do something to help your brain encode it. This is another way that you can actively organize things in such a way that it's easier for your brain to encode, which is sort of like we do with the slides, is to create these sort of mind maps, right? So extending duration, there's 2 ways to do it, either maintenance rehearsal or elaborative rehearsal. Maintenance rehearsal is simple repetition, whereas elaborative rehearsal, either you focus on the meaning and it's more effective. So if you can do this, and it doesn't mean you have to go and draw something like this for each one, but you'll notice like in the notes, this is what I've done here. Capacity and duration, 3 points. There's 2 ways of doing it. There's chunking, there's rehearsal. And under rehearsal, there's two types. There's maintenance rehearsal and there's elaborative rehearsal. So all of that is just in one there, and it's sort of done in layers, and that helps with encoding and organizing where the information is. Putting short-term memory to work. The first three-stage model that we talked about earlier in this video, cognitive science kind of consider that sort of model is now it's presenting memory in a passive way. And what they're saying is that working memory is more of a workspace where it's actively and simultaneously processes of different types of information and supports other cognitive functions. I'm sorry if that sounded badly. So, for example, the other model was saying that the working memory is like everything being put onto a loading dock of the brain, right? So the sensory information comes in. There's a loading dock. All of that information is put onto the loading dock, and some of that information off the loading dock is taken into long-term memory, and some is not. But the working memory is a little bit passive on its own. Okay, so newer ways of looking at it, cognitive scientists are saying it's not a loading platform where information just sits there and things are just sort of taken from working memory. They're saying that working memory itself is a very, very active part of the cognitive functioning. It's interacting with the sensory, it's interacting with long-term memory, it's interacting with everything. Problem solving, planning, whatnot. It's doing a lot of categorizing, cataloging, cross-referencing new information. So yeah, much, much more active place. A more current model of information processing is the four-component model. Okay, so it divides the working memory into four components: phenomenological loop, visual spatial sketchpad, episodic buffer, and central executive. Now I've made this episodic buffer purple for a reason, and you'll see why in a second. So the phonological loop has to do with auditory storage. So if and I'll just use the example in the text because I mean that's easy enough, right? So how much is 87 plus 36? So when I say that out loud, your auditory storage, it's going to be repeating 87 plus 36, 87 plus 36, right? You're going to hear that in your kind of and speaking it. Your visual spatial sketchboard. This is where you store and manipulate mental images. So your sketchpad is actually probably visualizing 87 plus 36. So you've got this auditory loop going on, right? Repeating it in your brain. You've got this sketchpad where you can manipulate mental images, spatial information. And then you have the episodic buffer. So in order for you to calculate 87 minus 36, you have to pull from your long-term memory like the rules for how to do that. So all this information from the phenomenological and the visual sketchpad go to the episodic buffer. And once it's in there, the episodic buffer, this workspace, is going to be pulling rules out of your central executive, the fourth one there, right? The central executive, it directs attention, recall from long-term memory, integration of input. It has involvement of the prefrontal cortex. The central executive, that's like the control process, the control center. It decides everything. And the interesting thing is research has found that emotion plays a role in how you emotion has a role in how the central executive functions and operates. So just let me clarify that. So the prefrontal cortex is where executive functioning happens. Okay, And what they're saying is the prefrontal cortex is heavily influenced by emotion. What that means is that when you're happy, you have enhanced working memory capacity. When you're unhappy and stressed and, upset, whatnot, it means that your prefrontal cortex is not going to be working at maximum performance. It'll have a decreased performance. And finally, the third part, long-term memory. Long-term memory storage capacity is thought to be unlimited. Okay, once you have things stored in your long-term memory, that can stay there for a lifetime. There are times when you possibly have difficulty retrieving it because it was not stored properly, but it is there. Serial position effect. I wonder if any of you have heard this, and this is an interesting thing to know for even for presentations and other things, and you'll see what it means is there's a U-shaped pattern to how recall works. Okay, so imagine if you're at a 3-hour lecture. Oh God, no, let's call it let's say just an hour-long lecture, right, at school. What they're saying is imagine a U on a graph. So your retention of information that's given in the first 5 or 10 minutes and the information that you retain at the end of that hour, you can have higher retention of that. And the information in the middle during that middle 20 minutes where you sort of daydream and or you're just overwhelmed with information, that information is not remembered as well. I'm going to show you a graph in just a second. Well, you have the slides, you've seen the graph. So primacy effect is superior recall of earlier words, rehearsed quickly, and you store them, right? Perhaps that's why. Your mind is free and blank and not stressed yet. So the information that you get at first, it's easy to store it and encode it. Then as the lecture goes on and on and on and on, the short term, it starts to fill up. And it gets very busy in there. So you're not able to encode and store things as well. The recency effect, which is information of the last 10 minutes of the lecture. This one's kind of hard to explain. It gets encoded and it's not being bumped out by later information. So we'll just take a look at here. Okay, so beginning of the lecture, your mind is clear, you're relaxed, everything is there, getting encoded, whatnot. So there's the U, right? It's not a great U, this one. Right? And then in the middle section here, your short-term memory space is just overwhelmed, right? And so you're not able to encode the same. So primacy effect, recency effect is superior retention of information at the end of the lecture. I was trying to think of an example for recency effect. Okay, so we go through this lecture. Well, we're almost there. Okay, we're coming to the end of the section on memory, right? So we've gone through all of this and we keep putting more and more and more information into your working memory. We've reached the end now. We're talking about recency effect, and there's not going to be any more information given to you. So recency effect would say that you should really be able to encode recency quite well because you're not putting any more information in there and it's not going to be replaced by something else. So serial position effect would mean that for this lecture, for this video, you will likely remember Henry and sensory memory and encoding. That would be the primacy effect, and then the recency effect would be you actually remembering the recency effect. Okay, so we've had the introduction, we've talked about memory as an information processing system, we've talked about sensory memory, short-term memory, long-term memory. The next video is going to be about encoding and how the information goes from short-term memory into long-term memory, how we actively do that. So I'll see you in the next video.